going to build this thing over here. It's a 15 kilovolt generator. What I'll do is go over the theory, the build, and then the demo at towards the end. And I'll list all the times over here. But first, a word of warning. All kits aren't necessarily built correctly. I've got 4 of these. This one and 2 of the other ones have the base on 1, the collector on 2, and the emitter on 3 for the transistor. One of the special kits, which has the exact same circuit board, has for the transistor, which is an NPN, the base is on 3. Plug this in, and nothing's going to go good for you. Also on this kit here that has the wrong part, the diode is also not the one that's in this other 3. The other 3 have UF4007. This one has a 1N4007. So different part. So for the theory on this, it's pretty, well, kind of straightforward. With the proper part in here, when you turn it on, and I'll use conventional current for this, the electrons flow through this one down here, up to here to the base, turning this transistor on. Because, of course, before this transistor is turned on, nothing's flowing through the primary, or the big primary. When this is turned on, all of a sudden current can flow through here, so you have a lot of current flowing through here. And when it does that, these are actually set opposite. They're wound in the same direction, but you connect them opposite. So as this charges up, it slowly decreases this one, and then that turns this off, and this thing starts oscillating back and forth, which is inducing the high voltage in the secondary here, because there's a lot more windings on the secondary. So next, let's assemble it. Time to assemble it. Start with the low components and work our way up. And this will be stop motion. Resistor, diode, with a nice little diagram. And trusty lead solder. Then attach the transistor to the heatsink, slide it in, and solder it up. Now the power switch, and solder. For the next part, you need to actually clean the enamel off the wires. I'm just going to use a tiny bit of sandpaper. Once that's cleaned off, the diagram shows taking these 2 and connecting them, and then these ones go in the other holes. So once it's nicely secured down, flip it over and solder, and I would recommend turning your iron up high in case there's any enamel that you need to burn off. And even with all that sanding, it was still very hard to get the solder on those wires. So the power leads are now on. With this here, what I'm going to do is take out the middle one, pull it out, and then solder it onto these wires. And now it's all ready for testing, except for one little thing. This was the first one I built, and I did all the testing on. And when I built this one, I forgot to turn the camera on. Yeah. So all the testing was done on this. Then when I started to compile everything, I realized I had none of the assembly stuff. So that's why I just did that one. But the testing will be with this one here. I have 4.76 volts on my supply setup. And you can see the arc. And it's currently melting the connectors. So what I've done is I've taken a thermocouple and attached it to the heat sink. I've got these roughly in the right position, as you can see by the arcing. And the alligator clip is holding the heat sink and the thermocouple together. So there's actually a nice little arc there. And I'm suspecting this transistor is not going to last long. A little huff and a puff. Moves the flame around, or the arc around, quite nicely. We're up to almost over 70 degrees. This might be a Puff the Magic Dragon coming up shortly. Yeah, 83. I'm pretty sure the transistor's not gonna last much longer. Still got a nice arc, and I do have my safety glasses on just in case. What's 100 degrees C? Maybe I should be doing a water cooling on this one. And let's grab something to burn. It's always good to burn something. Yeah, the sandpaper. Not a problem. So you're going to use this for lighting. Don't like using matches or a lighter. I guess it would work. We're up to 118 degrees C. I would have thought this thing would have melted down by now. So they do work. I think the transistor is for wattage probably underrated. Probably need a much bigger heat sink. Oops, and just turned off. Might just be, oh, got a back arcing. So cute little novelty. And for, I think this was 96 cents. Not bad. So that's one I did the first test on. Here's one I just built. And just to show that it does work. You can tell them apart because they have different wires coming out. And that's not a bad arc. I'm going to actually spread the arc. No, I can't because it would actually arc there then. Doom! Hey, you don't need the tip. It's just arcing across. And still going quite nicely. I'm just going to separate them a tiny bit. Let's see how far apart these will. Now that's a nice size screech from it. Yeah, I'm going to slip a different color behind there so you can see the arc a bit better. Okay, let's see. Yeah, loads of fun. That's it.